Hey YouTube, welcome back. Today we have the third solution. Yeah. Today we'll talk about the third solution about this problem. Today we will have a dynamic programming solution, a hot topic. Papa. So, let's read the problem first. Problem number 70: climbing stairs. You are climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? So, for example, we have 2. If the steps are 2, we can go to the second step by 2 ways. Go 1 step by 1 step, or jump directly to 2 steps. In 3, we can go there by 3 ways: 1 step plus 1 step plus 1 step, or 1 step plus 2 steps, and 2 steps plus 1 step. There's something quite interesting you can see here. If we broke this problem into some problems, so for example, if I'm going to 3, okay, I'm going to 1 step and 1 step, okay, and 1 step further, or 1 step and 2 step directly, or 2 step and 1 step. Let's just look at number 2 here. So number 2 is 1 step and 1 step. So you can see here 1 step here, or 2 steps, which is this one, and 1 step. So basically we have 2, n of 2 here also, and this one is built on top of 1. So it's anyway, if you can see that the amount, or the number of the distinct ways of to search to reach n3, it's actually equals the number to reach from n2, from 0 to n2, plus the number amount of reach from from 2 to 3. So basically, as we can see, this problem can be broken into sub-problems, and it contains the optimal structure property. So its optimal solution can be constructed efficiently from the optimal solution of its sub-problems. This doesn't make sense, but let's just try to write this into code, and I will talk about what is dynamic programming and why we consider this dynamic programming. And also I will talk about what is dynamic programming is, because this is one of the most important topics when it comes to problem solving. You'll find the dynamic programming often, specifically in this area, in this period. So let's just start to put some base cases. If n equals 1, we return 1, because this is what we know. If n equals 1, we return 1. So we can just we can create an array, okay, and this array will equal the new array, and it will equal from the stairs, but n plus 1, and we'll have dib. The thing that I'll put the first two, because we know that if dib of 1, db of 1, the db of 1 will equals 1, and db of 2 equals 2 also. Okay, these two base cases that we're putting. So I will do for loop. I will say from the third step directly, I equals 3, and I will say I less than or equal n, and I will say I plus plus, and I will say that db of I, it's actually equals the db of I minus 1, it's a previous, and plus the dB. Oh no, plus not multiple. Plus the dB of I minus 2, and directly I will return the dB of n. Let's just think about what's going on here. So this JavaScript code provide an efficient dynamic programming solution to the climbing stairs, okay, which calculates the number of distinct ways to climb staircase with n steps, and it uses an array we called db to store intermediate results and avoids recursion, because recursion is sometimes become too hard to understand. I guess if you saw my previous two videos, it was pretty difficult for me to describe it for you guys. So let's just go through the description about what's going on here. So we have the climbing stairs function takes an integer called n as an input, and it returns the total number of the distinct ways to climb the stairs with n steps. Okay, so number two, it first handles the base case. If n equals 1, there is only one way to climb one step, so we return immediately 1. The second, we initialize an array called db of size n plus 1 to store intermediate results. So db of I will represent the number of ways to climb the I steps. Okay. Number 4, db of 1 to there's only one way to go to 1, and db of 2, there's only there's 2 ways to go to climb 2, so we just put them to make it easier for us. After that, we use a loop to calculate the number of ways for each step from 3 to n. For each step of I, it sets db of I to the sum of I minus 1 and I minus 2. This because the number of ways to climb I steps is equals the number of ways to climb I minus 1 steps, and the number of ways to climb I minus 2 steps. And this recurrence relation represents the essence of the dynamic programming solution. After the loop completes, we return db of n. We make sure that we have db of n contains the total number of the distinct way to climb n steps. So the function returns db of n, which is the final result. And there is a pretty important one here that we are making n plus 1 here, because we want to start with step 1 directly. We don't want to start from step 0. If you can just make the array of n, but you have to add plus 1 in a lot of places. So let's just try to get this example. Let's just take the 3. So basically, I'm saying, of course, we have this one array, and it will equals n plus 1, so it will equals 4 values, and we save the first one 1, 2, and this one will be 0 also. Let's just fill it with 0. So right now I'll go with n equals 3, which it will start with I here. So we think that if you can see here, it's the amount of steps to go to 3 equals 3. The amount of steps to go to 1 equals 1, and the amount of steps it's to go to 2, it equals 2. So basically, I minus 1 plus I minus 2, the previous, and it's a previous of the previous. So basically, we return it directly, and this way, it's way more easy for us to understand. So the db of I, which is will be 3, which will be this one, will equals db of I minus 1, which 2 plus 1, which will be 3, so it will be 3. And after this loop finished, we return the db n of I, which will be 3, which will be this one, and we return 3. It's really easier. It's way more easier than the recursive function, and it's it's easier to understand. It's easiest to write, and it's a dynamic programming. But what is dynamic programming? This is the thing that we want to talk about. What is dynamic programming. Dynamic programming Dynamic programming is a powerful problem-solving technique used in computer science and mathematics to solve for problems by breaking them down into smaller subproblems and sorting the results of these subproblems to avoid redundant calculation. It's particularly useful for optimization and combinatorial problems where you need to find the best or optimal solution among many possible solutions. So for this one, we break the problems into some problems, and we make sure that we calculating the current solution based on our previous solution, like from I-1 and I-2. And there are some key values when it comes to dynamic programming. The first one we will say is that we're using memoization, and as you can see here, we was memoizing every result. The second, we are using recursion. We didn't use this recursion. We didn't use recursion here, but in maybe more advanced problems of dynamic programming, we will use recursion. And we break the problem into sub-problems and try to find the solution for our main problems based on solving each sub-problem by its own. And we did that by solving every previous step of the current step. So that's it for this video, and I hope you like my content. If you like my content, you should subscribe and hit the notification bell, so guys, you will never miss a video, and see you in future problem, guys.